Hello everyone. Let's start with the chapter of current electricity, and primarily what I'll be doing in this video is more of problem solving. So I've chosen few assorted problems, and doing these problems will give you a very good idea of what kind of problems you can expect in NEET. So let's start. The first question goes as follows. We have been given a wire and it's told to us that the current in this wire is 4.8 ampere. Alongside, what's been told to us is we have to find the number of free electrons passing through any cross section. Passing through any cross section per unit time. That's what we have been asked. So now we know that the basic definition of current, how do you give current? Current is defined as rate of flow of charge, delta Q by delta T. And if you go by the exact definition, I is given as limit delta T tends to 0, delta Q by delta T. Now this actually is also defined as dq by dt. Of course, we are not using this definition here, but then certainly we know that the charge can be defined as I is equal to NE by T, because Q is defined as number of electrons into the charge on one electron. And when I try to find this, what is actually asked is N by T. So all that we will do is 4.8 divided by 1.6 into 10 to minus 19. So what you get is N by T. Now this is coming to 16 minus 16, 16 3s are 48. And what you get is 3 into 10 raised to 19. This is the number of electrons flowing per unit time. So that is the answer to this question. Let's quickly see the next question. What's been given to us, let me describe the situation to you straight away. We have got two wires, wire 1, wire 2, and they have been connected in series. So wire 1 connected to wire 2. So let's consider that wire 2 is the BC part, wire 1 is AB part. The radius of both of them is the same. And what's given to us is the ratio of N1 by N2. What is N? N technically is carrier charge density. So carrier charge density is nothing but number of charges per unit volume. This quantity is called N, and that is the ratio of both of them. So carrier charge density in this wire and this wire. So that's N1 by N2. The ratio is 1:4. What we have been asked is to find out the ratio of drift velocities. So now we very well know one concept, that because it's a series connection, the current is going to be same in wire 1 and wire 2. And so we can write I1 equals to I2. Now we have a formula for I. The formula for I that you are supposed to know is NEAVD, where N is the carrier charge density, E is the charge on one electron, A is the area of cross section, and VD is the drift velocity. So that is same for both of them. So N1 E A VD1 and N2 E A VD2 is what we can write. So what happens is E into A and E into A. This goes and we get the ratio as VD1 by VD2, which is going to be N2 by N1, which is nothing but 4:1. That is the answer of this question. Let's take up another question. So it says that the current flowing through a wire is defined by the equation 1 plus 2t. That means along with time the current is rising. Find the charge through the resistor. That means this wire has a particular resistance. So they've called it a resistor, and we have to find the charge that is flowing through this wire from t equals to 0 to t equals to 1 second. Now whenever you get such a question, it is obvious that we have to use calculus because it's a variable current. But we know that by the definition, I is defined as dq by dt. We got to use this. So dq by dt is going to be written as 1 plus 2t. Now this is a differential equation which every NEET aspirant must be able to solve. dq will keep on one side and dt will take on the other side. So what will happen is this is what we'll get. Now integrate on both the sides. So let's say at t equals to 0, we didn't have any charge, 0. And this is 0 till 1 second. So I'll put 1 over here. In 1 second, so much charge got accumulated. So now basic integration that you people are supposed to know when you're doing such a kind of thing is that any algebraic function can be integrated like this. X raised to n, I can write it x raised to n plus 1 by n plus 1. Similarly, because it's a function of t now, this is something like x. So what we're going to do is, integration dt is t for this part. And integration of this part is going to be 2 t square by 2 from 0 to 1. So first we'll put the upper limit, then the lower limit. Ultimately what happens is, you get the answer is 2 coulombs. Because 1 will go here, 1, and 1 will go over here. So it will become 1 square. So 1 plus 1 square is 2. And then if 0 goes, 0 is subtracted, then what will remain is 2 coulombs. So that is the answer of this question. Let's have a look at this question now. We've been given 3 wires, W1, W2, W3. And these are the special features. That means all that you need to know regarding a particular wire is that length and area is what is given. Area means area of cross section. Now we have to compare their resistances. So let's say resistance of this is R1, resistance of this is R2, resistance of this is R3. So how do you find the resistance? Resistance of a typical wire can be given by the formula R equals to rho L by A. So we say that as far as length is concerned, resistance is directly proportional to the length and it is inversely proportional to the area of cross section. If that is so, then we will write R1 is, assuming that rho is same for all of them, that means rho is called specific resistance or resistivity of the material. Now if the material is same, let's assume that the material is same and we'll work it out. So rho L by A is the first one. R2 is going to be rho 2L by A by 2, which is 4 times rho L by A. And then comes R3, which is rho L by 2 by 2A. So what you get is 1 by 4 times rho L by A. Clearly, we can see now that if you consider this quantity as some R, this is going to be 4R and this is going to be R by 4. So order is there in front of you. We can clearly say that the least is R3, then comes R1, then comes R2, which is the highest. Let's see another variation of this. So this is a very important concept. Let's say we have a wire which is having this kind of a cross section. Now if it is stretched so that its length increases, it will look like this. So what has exactly happened with this is that, I think I need to show it a little smaller. What has actually happened? It's a uniform cross section. My diagram might not be so proper, but I believe that you can clearly spot the difference that this cross-sectional area and this cross-sectional area is different. That means the overall volume has remained same. But if you increase it, if you increase its length, what has happened over here is the CSA, that cross-sectional area has come down. So in both the cases, volume has remained the same. And because of which I can write A1L1 equals to A2L2. So let us say you increase the length n times. If you increase the length L times, we know that L2 can be written as n times L. So original length is some L, let us say. So A1 I can say is some A, this is L, and this becomes n times L. What happens to the area? Area reduces by n. That is what we understand. Area reduces by n. So if earlier our R was rho times L by A, now R dash will look like rho, because rho will not change. It's the same material that we're using. L will become n times L and area will become A by n. Overall what has happened is n square rho L by A. This has happened, and this is R dash. So what I can write is R dash is N square times R is what we can write. So when volume remains constant, this is a very important expression that you have to remember. Now let us say that we have got a similar situation and the wire is stretched in such a way that diameter becomes half. Diameter becomes half of original. So that means I can surely say that D2 is D1 by 2. Now if D2 is D1 by 2, certainly we can say that area is directly proportional to D square, square of the diameter or square of the radius, because it's pi r square or pi d square by 4. So D2 is equal to D1 by 2, which means that A2 is A1 by 4. This is the information that I get. Not only that, I can also make a conclusion from here that L2 is 4 times L1. Clearly, now we have the factor in front of us. We know that the factor n is 4 over here. So if the area reduces by 4, the length will increase 4 times. And if that is so, the resistance R dash, new resistance will be 16 times R, going by this formula. So this is what you have to learn from this problem. So the next question is a recent NEET question which says that there is a copper wire in which a current of 10 amperes is flowing. And what are the information is given to us? The radius of the cross section is 1 mm. The number of electrons flowing per unit volume is 10 raised to 22. We have to find the drift velocity. Now the formula that we know already is this. What we really want to find is drift velocity. So drift velocity is going to be I by NEA. So I is already given to us. Let's put that 10. Number of charge carriers is 10 raised to 22. Electronic charge is going to be 1.6 into 10 raised to minus 19. And area of cross section, that is indirectly given to us, that's a radius. So 1 mm, that means I got to write pi 10 raised to minus 3 the whole square. This is what I get. Now the best way to do such a calculation, as we all know, is first club up the powers of 10. And that makes me say that this is going to be 10 raised to 21. First of all, 10 raised to 21 raised to minus 19 is going to be 10 raised to 3 here. So we're going to get 1.6 pi, let's keep it outside, 10 raised to 3, and this is going to be 10 raised to minus 6. Overall, what remains over here is 10 raised to 3, which if I rub off, it will go on top as 10 raised to 3. Now 1 by 1.6, this factor is nothing but 0.625. This factor comes often, and you will see this factor coming in electrostatics when you're trying to convert charge to the number of charge carriers. So 1 by 1.6 is 0.625. If that is so, then 0.625 into 10 raised to 3 divided by pi is what you get. And so I can write 6.25 into 10 raised to 4, or rather 10 raised to 2 in this case, divided by pi. That is the answer of this question. And I got to write meters per second because that is the SI unit. That is the answer of this question. So I think there is a slight correction here. This is 10 raised to 21, 10 to minus 19. So 10 raised to 2 will remain here. And what will remain over here is 10 raised to minus 6. So 10 raised to 2 and 10 to minus 6. When multiplied, what remains is 10 to minus 4 is the balance. Take it on top as 10 raised to 4. And already we know that 1 by 1.6 is 0.625. So this will be 10 raised to 4. Ultimately, the answer that you should be getting is 6.25 into 10 raised to 3 divided by pi meters per second. That should be the answer. Let's take the next question. There's one more wire given to us, and this time we are asked to find current density. What all parameters have been given? R is given to us. R is 10 ohms. That means the resistance of this wire is 10 ohms. The length of this wire is 10 meters. The radius of the cross section is 10 to minus 2 by root pi. Direct question. Now, yes, all these parameters are of importance. When you have to use, you can also have one other formula, which is J equals to sigma E. Now, if conductivity or resistivity are given, in that case, we can always use this. Of course, we're going to deal with this later. But for now, looks like we're going to get a direct answer from here. J is nothing but I by A. So I is given as, okay, I is what we need to actually find out. So V sigma J equals to sigma E. Sigma is nothing but conductivity. Sigma I can write as 1 by rho, where rho is resistivity. And this E, we are going to make a good use of it. J is our target. So rho I can write now, as we know, R is given as rho L by A. So all that will come now. And rho I can write as RA by L times rho. So let's put it here. And from here, 1 by rho is what? L by RA. This is what we know. So L by RA into E. So all the parameters are there with us. Length is given. Length is 10. E is there with us, which is 10. Resistance is there, which is 10. And area would be nothing but pi r square. But r is this, so square of it is going to be 10 to minus 4 by pi. Square of this quantity is going to be 10 to minus 4 by pi. So this and this will go, ultimately 10 and 10 will go. What we have on top is 10 raised to 5. That is the answer of this question. So what is the unit of current density? Simply, it's going to be ampere per meter square. So ampere for current and meter square for area. So this, the formula, the learning out of this particular problem is this formula. J equals to sigma is what we are using. Now because current is not given to us directly, we cannot use this particular part. And so the other modification that you should know is conductivity is nothing but 1 by resistivity. And we have written the formula for 1 by rho from here, this flow. That's how we get the answer. This time around, drift velocity of the charged particle is given to us. Electric field in the conductor is given to us. Electric field in the conductor means electric field which is associated with the conductor. And what is asked is mobility. So this quantity, this symbol is for mobility. So how is mobility defined? Mobility is defined as drift velocity per unit electric field. That's how it is defined. So drift velocity is given as 7.5 into 10 raised to minus 4 divided by the electric field, which is 3 into 10 raised to minus 10. If you do this calculation, this is going to be 2.5 into 10 raised to 6. Now comes the unit. So unit is going to be really important. We know that drift velocity is meter per second, and we know that electric field we can give as volt per meter. So combining all this, we would get it as 2.5 into 10 raised to 6 meter square voltage inverse second meters. This is the unit of mobility. Quite important from the examination perspective. So anything could be asked regarding mobility. You could be either asked the dimensional formula, you could also be asked to calculate mobility, or you could be asked the unit, something related to this. So the unit is very important. The next question is given as follows. Given that we have a conductor which is connected across a battery. So the specialty of this conductor is that it's not a uniform conductor. It's a non-uniform conductor, as in here there is one cross section, and as you go from here to here, the cross section is increasing. That means it is non-uniform cross section which is there. Which of the following quantity is a constant in such a conductor? These are the 4 options. Let's talk on all the options. First, let's talk about drift velocity. Drift velocity, if you consider, it is given as E times E by m into tau. Let's talk about this magnitude. So this is the quantity now, and E into E by m into tau. Certainly, electric field is going to be a variant over here. As you go from this end to this end, electric field is definitely going to vary. And apart from that, let's talk about this electric field. We just spoke about it, that it is varying. So drift velocity along with that is definitely varying. What about J? Now J is a quantity which is dependent on area of cross section. So area of cross section is something that's varying from point 1 to point 2. So it is not going to be same. And current, how do we define current? Current is definitely given as charge flowing per unit time. So in this particular case, we can clearly say that current is the quantity which is going to be constant in this case. The next question says that the mean free path of electrons in metal is 4 into 10 raised to minus 8 meters. Now what is mean free path? So the electrons are going from one end to the other, and as they go from one end to the other, they experience whole lot of collisions. The average amount of path that is covered by the electrons is the mean free path. That is given as 4 into 10 raised to minus 8. So you can say the length. What's the information that's given to you is the length. Electric field required to provide an average energy of 2 electron volts to all electrons in the metal will be dash. That's what is asked. So let's start with the calculations. We know that energy can be given as E into V naught. E into V naught, or Q into V is the amount of energy given to a charge. So energy already is mentioned to us, that is 2 electron volts, which means that the potential that you are supplying is 2 volts. This is the information that we get from you. The amount of potential that you have supplied is 2 volts. Now we know that E is V by L. So the potential that you have supplied is 2, and the length that is covered by the electrons is 4 into 10 raised to minus 8. That is also given. So 2 ones are 2 twos are, we'll get 0.5 into 10 raised to 8 on top. This is Newton per coulomb, because we are giving electric field. So the unit of electric field is Newton per coulomb, and this is going to be 5 into 10 raised to 7 Newton per coulomb. That is the answer of this question. We've got 2 wires now, both of the same material as mentioned, and both of the same length. Resistance of A is 81 ohms, and what's given to us is diameter of B is 3 times diameter of A. We have to find the resistance of RB. So which formula do we use? We can, as discussed earlier, we can use R equals to rho L by A. Now rho and L both are constants, which means that resistance is inversely proportional to A, and I can write R1 by R2 is A2 by A1, and R2 from here certainly is going to be R1 A1 by A2. So we know that A1 by A2, from here we know that dA by dB is 1 by 3. So area of A by area of B, this ratio, or A1 by A2 is going to be 1 by 9. So A1 by A2 is going to be 1 by 9. R1 is 81 into 1 by 9, which comes as 9 ohms. That is the answer of this question. So the next question is as follows. We have got a platinum wire, and what's given to us is that at 0 degrees centigrade, the resistance is 2 ohms, and at 80 degrees centigrade, the resistance is 6.8 ohms. So resistance is improving, increasing. What we got to find is the value of alpha. Alpha is temperature coefficient of resistance, and the formula that we know regarding this is RT equals to R naught into 1 plus alpha delta T. So you can also write it as RT, or in this particular case R2 equals to R1 to 1 plus alpha T2 minus T1. Let's do this. And we're going to find alpha. R2 is given as 6.8. This is 2. 1 plus alpha is unknown. T2 minus T1. Earlier it was 0. Now it is 80. So this is 80. So this is going to be 3.4 minus 1 divided by 80. This is alpha. 3.4 minus 1 is 2.4. 2.4 by 8. We can write this as 2.4 by 8 into 10 raised to minus 1. So 8 into 0.3. That's what we get. And going by this, we're going to get 3 into 10 raised to minus 2 per degree centigrade. That is the value of alpha.